In this video, we prove one of the most famous results in mathematics. There exists no rational number whose square is equal to 2. We proceed by contradiction. Assume that there exists a rational number whose square is 2. Then we can write square root of 2 as p by q, where p and q are integers having no common factor. Squaring both sides gives 2 equals p square by q square. Multiplying by q square, we obtain p square is equal to 2q square. Since 2q square is even, p square must also be even. The square of an odd number is odd, so p itself must be even. Therefore, we write p is equal to 2m for some integer m. Substituting p is equal to 2m into the equation, we get 2m whole square is equal to 2q square. That is 4m square is equal to 2q square. Dividing by 2 gives 2m square is equal to q square. That is q square is equal to 2m square. Therefore, q square is even and hence q itself must also be even. We have shown that both p and q are even, meaning both are divisible by 2. But this contradicts our original assumption that p and q have no common factor. Therefore, our assumption was false. Hence, there exists no rational number whose square is 2. In other words, square root of 2 is irrational.